There is a moment every gardener knows. You walk out in the morning, coffee in hand, and something stops you mid-step. A plant that was performing beautifully last week is now telling a different story. Leaves the color of old parchment, stems that have lost their uprightness, flowers that closed 3 days ago and haven't reopened. The immediate instinct, the one that most gardeners act on without thinking, is to reach for the shovel. To pull the thing out, toss it on the compost heap, and tell yourself it was a bad plant in a bad season and there was nothing to be done. Soil scientists who study what actually happens in the moments before a plant appears to die have found something that changes that instinct completely. In almost every case where a healthy plant suddenly declines, where leaves yellow, where stems sag, where flowering stops, the plant is not finished. It is not dying from disease. It is not beyond saving. It is starving. Running out of one or two specific nutrients that the soil can no longer supply in adequate quantities. And those nutrients, every single one of them, can be delivered in as little as 48 hours using materials that are almost certainly sitting in your kitchen right now. 5 materials, 0 cost. Results that university soil labs have measured, that generations of farmers used long before synthetic fertilizers existed, and that the modern garden industry has quietly moved away from for one simple reason. There is no profit margin in a banana peel. No packaging to design, no patent to file, no premium shelf space to sell. The garden center cannot make money from what you were about to put in the trash this morning, which is precisely why you've never seen it displayed next to the blue crystals and the slow-release pellets. This is the story of those 5 materials, what each one does, why each one works faster than anything sold in a bag, and the specific mistakes that most gardeners make that prevent these methods from delivering the results they're capable of. Because each one of these approaches works extraordinarily well when used correctly and produces disappointing results when one critical step is skipped. And that step is almost never the one people expect. Let's start with the one that most people throw away without a second thought. Number 1 is onion peel tea. Before the next onion skin goes into the trash, consider a question worth answering honestly. Which part of an onion carries more potassium? The white bulb that goes into the soup, or the dry, papery outer skin that gets peeled off and discarded? The answer surprises almost everyone who has never looked into it. The skin, those dry, papery, seemingly worthless outer layers that have been considered kitchen waste for as long as kitchens have existed, carry one of the most concentrated doses of potassium, calcium, magnesium, and iron found anywhere in the produce aisle. They also carry a compound called quercetin. This is the same compound that makes red wine, apples, and blueberries protective for human health. Inside a plant, quercetin does similar protective work. It shields leaves from harsh summer sun, slows the spread of fungal infection, and steadies the plant's internal chemistry when a heat wave or cold snap rolls through. A plant with access to quercetin is running a more robust immune system than one without it. And the source of that quercetin is currently sitting in your kitchen trash can. Here is where most gardeners make the first wrong turn when they discover this. They hear about onion peels and they imagine burying the skins directly in the soil, tucking them around the base of a struggling plant and expecting the roots to absorb the nutrients as the skins decompose. That approach works, but it takes weeks. The nutrients remain locked inside the dry plant fibers while the declining plant above continues to worsen. By the time the skins have broken down enough to release anything useful, the plant that needed rescuing may already be beyond saving. The correct approach comes down to something most people learned in grade school and forgot: water extracts. The same way a tea bag releases its contents into hot water, an onion skin releases its minerals into water at room temperature. The process requires nothing more than a handful of dry outer skins, a quart jar, and cool water from the tap. Leave it to steep for 24 to 48 hours at room temperature and watch what happens to the water. Within a day, it begins to darken, turning first to the pale amber of weak tea, and then deepening over the second day to a rich, dark amber that looks almost like apple cider vinegar. That color is not coincidental. It is potassium, magnesium, calcium, and quercetin compounds physically leaving the plant tissue and dissolving into the liquid. Once those minerals are in solution, they are in a form the plant's roots can absorb immediately. No composting required, no waiting for microbial breakdown, no delay between application and availability. Poured at the base of a yellowing tomato or around a pepper that has stopped setting fruit, this amber liquid begins to produce visible results within days. Stems regain their uprightness. New leaves emerge in deeper green. Flower production resumes. The plant's own immune response strengthens. Stem rot slows, seedling wilt fades, and the plant that looked finished on Thursday is still standing and performing at the end of the season. The mistake that most people make with onion peel tea is impatience, pulling the skins out of the water after a few hours before the extraction has had time to complete. The 48-hour window is not arbitrary. The first 12 hours extract the surface minerals. The second 12 extract the deeper compounds, including the quercetin. The final 24 hours are when the liquid reaches its full concentration and full effectiveness. Pull the skins out early and you have mildly mineral-rich water. Leave them the full time and you have a genuine plant rescue tonic. Number 2 is fermented rice water. There is a liquid that most households pour down the drain every time they cook rice. The cloudy, starchy water left over from rinsing the grains before cooking, the water that appears in the sink for a few seconds and then disappears with a single twist of the faucet. That liquid, or more precisely what that liquid becomes after being left at room temperature for 3 to 5 days, turns out to be one of the most powerful soil treatments ever studied under a microscope. Fresh rice water from rinsing is mildly useful. It carries starches, B vitamins, and small amounts of iron and zinc that benefit the soil in a general way. This is the version most people who have heard of the method use, and it works, but only marginally, and only in the way that any dilute nutrient solution works. The transformation that makes fermented rice water genuinely extraordinary happens after the liquid has been left to sit in a covered jar at room temperature until it develops a faint, sour smell. Most people pour it out at exactly that moment. The smell triggers the same instinct that makes us throw away food that seems to be turning. In this case, that instinct is throwing away the most valuable part of the process, because that faint sour smell is not a sign that the water has gone bad. It is a sign that lactic acid bacteria and wild yeasts have colonized the liquid and transformed it into something categorically different from what it was when it came off the rinse. The research of Japanese agricultural scientist Dr. Teruo Higa, whose work on effective microorganisms has been adopted on farms in more than 150 countries, explains what happens next. When this fermented liquid is applied to garden soil, the bacteria and yeasts it carries meet the microbes already living around the plant roots. The starches and sugars in the rice water act as a food source for the existing soil microbiome, waking it up, accelerating its activity, and triggering a multiplication of beneficial organisms that can triple the microbial population around a treated plant within a single week. And this is the moment where the entire concept shifts for most gardeners who try it properly for the first time. The fermented rice water does not feed the plant. It builds the plant's support system. It is the difference between handing someone a single meal and handing them a working kitchen. The meal runs out, the kitchen keeps producing. A plant with a thriving microbial community around its roots has access to nutrient cycling, disease suppression, and moisture retention that no synthetic fertilizer can replicate. Because synthetic fertilizers feed the plant while bypassing the soil ecosystem entirely. Fermented rice water does the opposite. It ignores the plant and rebuilds the world beneath it. The critical mistake that prevents this method from working for most first-time users is skipping the fermentation entirely. Fresh rice water produces modest results. Fermented rice water, 3 to 5 days old, carrying that faint, sour tang, is a completely different tool. If the liquid does not smell faintly sour, it is not ready. It can sit another day. The dilution step matters equally. Fermented rice water should be mixed at approximately 1 part rice water to 10 parts plain water before application. Undiluted, The acidity of the fermented liquid is strong enough to irritate tender roots, particularly in seedlings. Diluted correctly, it is gentle enough to apply every week throughout the growing season, gradually building the soil ecosystem that turns a struggling garden into a thriving one from the ground up. Number 3 is vegetable scrap digestate. Every refrigerator in a household with a garden contains a supply of fast-acting nitrogen that is currently being routed to either the trash can or, at best, a compost bin that will not produce anything usable for another 6 months. The forgotten tomato softening at the bottom of the crisper drawer, the head of lettuce that wilted before anyone got around to using it, the bruised cucumber pushed to the back of the shelf last Tuesday. These scraps are nitrogen in disguise, and the method that extracts that nitrogen and delivers it to a struggling plant in a form it can absorb within days is both older and more scientifically validated than most gardeners realize. The science traces back to a German chemist named Justus von Liebig, one of the founding fathers of modern agricultural science, who proved in the 1840s that plant growth is determined not by the nutrients a plant has in abundance, but by the single nutrient it has the least of. He called this the law of the minimum. Picture a barrel made of wooden staves of different heights. The water it holds can only rise to the level of the shortest stave, regardless of how tall the others are. Plants work identically. A tomato plant with generous potassium and adequate phosphorus, but insufficient nitrogen, stops growing at the nitrogen line. Everything else it has becomes irrelevant until the nitrogen shortage is addressed. In nearly every American backyard vegetable garden, nitrogen is the shortest stave. And green kitchen scraps, overripe tomatoes, soft peppers, wilted spinach, bruised kale, aging cucumbers, carry what soil scientists call a low carbon-to-nitrogen ratio. In plain terms, they are densely packed with nitrogen relative to their fiber content. That nitrogen, currently sitting in the trash can, is exactly what the struggling plant across the yard needs. The extraction process requires a 5-gallon bucket, the scraps themselves, water enough to cover them completely, and a plate or weight to keep everything submerged. Left to ferment for approximately 2 weeks, bacteria in the water break the plant cells apart and release the nitrogen locked inside the tissue into the liquid, a process called nitrogen mineralization that happens far faster in water than it would in a compost pile. The finished liquid is dark, cloudy, and strong-smelling. That smell is confirmation that the process has completed. Diluted at 1 part scrap liquid to 30 parts fresh water and applied directly to the root zone of a declining plant, visible improvement appears within 4 to 6 days. Pale, exhausted leaves deepen to full green. New shoots emerge from leaf axils where none were forming. Stems thicken at the base. The mistake that damages more gardens than any other error with this method is applying the liquid directly to leaves or using it undiluted. Both are genuinely harmful. Undiluted, the liquid is concentrated enough to burn root hairs beyond recovery. Applied as a foliar spray, it scorches leaves on contact. The correct application is to the soil at the base of the plant. At the correct dilution, never stronger and never on the foliage. Number 4 is the full-spectrum kitchen cocktail. Every struggling plant has a slightly different combination of deficiencies. One may be short on potassium, another on calcium, a third on nitrogen and magnesium simultaneously. A single ingredient remedy addresses one shortage at a time, which works when the diagnosis is precise and the deficiency is singular. But most plants that are visibly declining are missing several nutrients at once, in different amounts, at the same time. What that situation calls for is not a single ingredient, but a complete recipe. One built entirely from materials already present in the average kitchen, and designed to cover the full spectrum of what a struggling plant is most likely to be missing. That recipe has 5 components, and each one does a specific, irreplaceable job. Banana peels provide potassium, the mineral that drives flowering, fruiting, and the plant's fundamental ability to move water through its cells. A tomato plant short on potassium produces small, watery fruits with skins that split at ripening. A pepper short on potassium stops setting fruit entirely. 3 or 4 banana peels torn into rough pieces and added to the brew deliver this deficiency directly. Crushed eggshells provide calcium carbonate, the building block of plant cell walls. Calcium deficiency is the cause behind one of the most frustrating and most common sights in any tomato garden, the black, sunken patch at the bottom of an otherwise beautiful fruit known as blossom end rot. It is not a disease, it is not a pest, it is a calcium shortage, and crushed eggshells dissolved slowly into the brew address it directly and permanently. Used coffee grounds, the kind left in the filter basket after brewing, not fresh, unbrewed grounds, add a slow release of nitrogen and improve the physical texture of the soil around the roots. This is the point where mainstream gardening advice most consistently misleads people. The claim that coffee grounds acidify garden soil is a myth built on a half-truth. Fresh, unbrewed grounds are indeed acidic. Used grounds, the kind this recipe calls for, measure between 6.5 and 6.8 on the pH scale in university soil lab testing. Nearly neutral. They will not acidify a garden bed. What they will do is add organic matter, feed earthworms, improve drainage, and release nitrogen slowly across several weeks. Epsom salt, technically magnesium sulfate, addresses the fourth deficiency. Magnesium sits at the exact center of every chlorophyll molecule in every green leaf that exists. Without adequate magnesium, there is no chlorophyll, and without chlorophyll, there is no photosynthesis. When magnesium runs low, leaves yellow between their veins while the veins themselves remain green. A pattern called interveinal chlorosis that is one of the most recognizable nutrient deficiency signs in the garden. 1 tablespoon of Epsom salt dissolved into the brew delivers a direct magnesium correction that can reverse this pattern within days. The critical caveat belongs here because this is where well-meaning gardeners consistently cause problems. Yellowing leaves have many causes. Nitrogen deficiency yellows the oldest leaves first. Iron deficiency yellows the youngest. Overwatering and root rot can yellow the entire plant simultaneously. Epsom salt corrects magnesium deficiency specifically. When that is the cause, the transformation is dramatic. When the cause is something else, repeated applications of Epsom salt will eventually unbalance the soil's nutrient ratio in ways that create new problems. Diagnose before treating. Look at which leaves are yellowing and where the pattern begins. The 5th ingredient is blackstrap molasses, the dark, almost bitter version from the final boiling of sugarcane, not regular table molasses. A single tablespoon added to the brew does something that no gardening website explains clearly. It acts as a microbial catalyst. Molasses is exceptionally rich food for the beneficial bacteria in the liquid. Within hours of being added, those bacterial populations multiply dramatically, and those hyperactive microbes then break down the banana peels, eggshells, and coffee grounds far faster than the ingredients would decompose without them. A brew without molasses takes 3 weeks to reach full effectiveness. The same brew with molasses is ready in 3 days. That single tablespoon is the difference between a slow-release fertilizer and an emergency rescue tonic. All 5 ingredients go into approximately 1 gallon of warm water in a covered bucket and steep for 3 to 5 days. The result carries potassium, calcium, nitrogen, magnesium, iron, trace minerals, and a live culture of working bacteria in a single pour. Applied at the root zone, never as a foliar spray, always diluted to roughly 1 part brew to 10 parts water, it begins producing visible improvement within a week. Number 5 is aged manure tea. Before 1913 and the invention of synthetic nitrogen fertilizer, every garden on Earth ran on 2 inputs, animal manure and compost. The Haber-Bosch process that followed changed agriculture permanently, feeding billions of people and simultaneously stripping the microbial life from cropland across most of the industrialized world over the following century. That is the trade-off almost no gardening book explains honestly. Synthetic nitrogen fed the plant while starving the soil beneath it. The old method did both simultaneously. Among old-time farmers in Appalachian Hills and Pennsylvania countryside, the method has a name: manure tea. The setup is as simple as anything on this list. A shovelful of aged, dried manure, from chickens, cows, or rabbits, never fresh, goes into a porous sack. An old cotton pillowcase works perfectly. So does a burlap feed bag or a mesh laundry bag. The sack is tied shut and dropped into a 5-gallon bucket of water. Over 3 to 5 days, the water slowly extracts the soluble nutrients: nitrogen, phosphorus, potassium, and a long list of trace minerals, leaving solid matter safely inside the sack where it cannot burn roots or carry weed seeds into the garden. Each manure type has a different profile, and the choice matters. Aged chicken manure carries the highest nitrogen and phosphorus levels, making it the most powerful growth stimulant. A single cup of chicken manure tea properly diluted can push a tired tomato plant back into heavy flowering within a week. Aged cow manure is more balanced, lower in nitrogen, but exceptional for building long-term soil structure and feeding the humus layer. Rabbit manure is the quiet secret of experienced gardeners. The only common manure that can technically be used raw without burning roots, making rabbit-based tea the gentlest and safest option for young seedlings and established plants alike. The mistake that destroys more gardens than any other error with this method is using fresh manure. Fresh droppings from any animal carry ammonia concentrations strong enough to scorch an entire row of seedlings within 48 hours. They also carry weed seeds and pathogens. The manure must be aged, ideally 6 months to a full year, before it goes into the tea bag. There are no shortcuts on this requirement. Once brewed, the finished liquid gets diluted to the color of weak iced tea, approximately 1 part manure tea to 10 parts clean water, before it touches any plant. Applied in the cool hours, early morning or the last hour before sunset, the soil retains the nutrients most effectively. In midday heat, significant nitrogen evaporates before roots can absorb it. In the cool of evening, the plant drinks at its own pace through the night. 5 fertilizers, 5 methods, each one already present in the kitchen, the garden, or the shed. Onion peel tea delivering potassium, calcium, magnesium, and quercetin to roots that can absorb it immediately. Fermented rice water rebuilding the microbial ecosystem beneath the soil surface. Vegetable scrap digestate addressing the nitrogen shortage that stops growth in its tracks. The full-spectrum kitchen cocktail covering the complete range of likely deficiencies in a single 3-day brew. Aged manure tea providing the full nutrient profile combined with the living microbial culture that helps the plant actually use what it receives. What connects all 5 is a single principle that modern gardening has largely forgotten. The materials most often called waste in a contemporary kitchen are almost always the exact inputs that a struggling garden needs to come back to life. Every kitchen that redirects even a fraction of that waste stream back toward the soil will, within a single season, produce plants that are more vigorous, more productive, and more resilient than any amount of purchased fertilizer would have made them. The plant at the edge of your garden that looks finished this morning probably isn't. It is almost certainly just waiting for something specific. And that something is very likely already in your kitchen. Sonnet 4.6. Thank you for watching this video. Click here to watch another video that might interest you.